All right, so let's talk about the domain and the intercepts of a rational function. So to find the domain of the rational function, we want to think about what that question was before, finding the restrictions to the domain. In order to do that, you always set the denominator equal to 0 and solve. Okay, so let's actually, before we go on, we'll actually do that in these examples. So find the domain of each rational function. Essentially, what number would give me 0 in the denominator here? -4. So for the domain, since that would give me undefined, I'm going to say you can use all numbers except -4. And that's what that says in set builder notation. It's saying the domain is x such that x cannot equal -4. What about here? What's the restriction on the domain? 2. If I get 2, if I use x equals 2, then I will have 0 in the denominator, which is undefined. Okay, what about the next one? X such that x cannot equal 4, right? And then what about here? Also 4. Okay, so essentially, if you didn't know for sure what it was, like let's say it was more complicated than that, you could literally take x minus, or 4 minus x equals 0, and then you could solve for x, get x by itself. That's what we're doing. We're setting the denominator equal to 0, and then we're solving, okay? Now, for the x-intercepts of a rational function, because we said with a fraction, remember we said if the fraction is going to equal 0, what about the fraction has to be 0 in order for the fraction to equal 0? The numerator. So that's why this says right here, you're going to set the numerator equal to 0 and then solve for x. So right here, if I set the numerator 8 equal to 0 and I solve for x, what happens? Well, 8 cannot equal 0, so then what's the x-intercept here? There's no x-intercept. If there's no x value in the numerator to solve for, and 8 cannot equal 0, then you would have no x-intercept. That was similar to the problem we had before. So what about this one? You're setting the numerator equal to 0. 8 equal to 0 and solve for x. 8 does not equal 0, so we say there's no x-intercept. Good. What about this one? I'm going to go 2x plus 8. I'm going to set that equal to 0 to find out what number the numerator would have to be. What would you get? -4. Okay, you did all of that work on your own page. Hopefully that wasn't too much skipping steps. X plus 8 equals 0. I'm setting the numerator equal to 0. And what would I get here? Yes. And so, by the way, if these are intercepts, then what's the ordered pair? If we're finding the x-intercepts, I wouldn't just have x equals -4. I would have an ordered pair on the graph, which would be -4, comma 0. And then here would be -8, comma 0. So the x-intercepts, I do want to see them as ordered pairs, okay? So that's how we find the x-intercepts of rational functions. For the y-intercept, we said the y-axis. What's the equation of the y-axis? X equals 0, right? And then we're going to get our y value. So if you plug in, essentially for all of these, you're going to find f of 0. Find f of 0. So we plug in 0. By the way, this one was solve f of x equals 0. That's the difference between the x-intercept and the y-intercept. So the y-intercept, when x is equal to 0, what do we get? F of 0 equals 8 over, what's 0 plus 4? And 8 divided by 4 is 2. So what's that ordered pair? Perfect. Okay, what about this one? I'm going to plug in 0. So I have f of 0 equals 8 divided by what? When I plug in 0 for x, what's left? 2. So I get 4. And so what's my ordered pair? 0, 4. Good, because the x is 0, the y is 4. Okay, here's same thing. F of 0. And do you notice how when you plug in 0 here, that's gone? The only thing left is 8 in the numerator. What would be left in the denominator? Negative 4. And what's that? And so the ordered pair is perfect. You're doing great. Okay, here, f of 0. I have what's left. If I plug in 0 here and here, I would have 8 divided by 4, which is 2. And so my ordered pair is 0, 2. Any questions about x-intercepts, y-intercepts, and domain?